This is part 2 of the video lecture on Chapter 15, Non-Renewable Resources. Last part 1, we ended talking about natural gas extraction and how there are a lot of environmental consequences on environmental gas extraction. And the last type of non-renewable energy we're going to talk about is nuclear power. So nuclear is actually not the non-renewable energy, but actually the uranium that is used to create the nuclear energy is what is in limited supply. So the sources and the amounts, it uses heat generated by the fission of the atoms. And it uses the decay of uranium to do this, to create this heat. In nuclear fission, the nucleus of the atom splits to form 2 or more smaller nuclei. In the process, a small amount of the nucleus's mass is converted to electromagnetic and kinetic energy. Nuclear fission occurs naturally when radioactive isotopes decay. But indeed, this process of decay, and this is what heats the Earth's interior, but electrical power is generated by taking advantage of this release, and we do it in controlled environment. Okay, so what we do is the decay of the isotope of uranium 235U. When the 235U nucleus is split, high energy neutrons are emitted, as well as other forms of energy, and if these neutrons are significant or sufficient enough abundant, they can split the nuclei of the other atoms and create heat. And this is what does this. So this just shows you, like other primary energy resources, uranium ore, which is what we use, is found in large quantities and, of course, relatively few locations around the world. You can see this is where most of it is found, and I'm just going to talk to you about how this happens. So uranium is extracted by open mine pits. That uranium ore is then crushed into this fine powder. It's made into what they call this yellow cake. This yellow cake is converted into a gas, and then the centrifuge to produce these pellets. They almost look like Rolos. I know that sounds weird, but they're these yellow Rolos. And what happens is then each one of these Rolos are stacked on top of each other and put into these rods. So all these long rods. Then these rods are packed into these assemblies, and they are 100 or 300 of these rods are put together, and that is what we call the reactor core, all right, inside. These get extremely hot. They need to have constant water source running through to keep them cool. And so, this is what happens and in these uranium core. So they join together to make this fuel assembly. Inside a nuclear power plant, up to 3,000 fuel assemblies are placed in reactor core, where the fission reactions will take place. This is just showing you an open mine that extracts it. This is showing you the yellow cake, which is made into these fuel pellets. They're put into these rods. This is how the fuel assembly happens, made into these reactor cores. What happens is these reactor cores are here, water, okay, which actually has to constantly cool these reactor rods. This is what causes those meltdowns. This is where the reactor rods are located. They're usually located in these things. This is surrounded by cement, and almost a jetliner can't even fly into this because it's so core. The problem, what happened in Fukushima and in Chernobyl, was that this got too hot. And when this got too hot, it caused a fire which melted the outside wall. Once this outside wall is melted, it's exposed to the air, and nuclear radiation gets out into the atmosphere, which is a huge problem. And that is what the big deal is. That's why in Fukushima, they just started taking, and both in Chernobyl too, they just started pouring water. In Fukushima, they just poured salt water as much as they could. In Chernobyl, what they did is they started pouring cement on here. And now we have a big problem where in Chernobyl, the cement that they poured on there is now starting to crack, so nuclear radiation is getting back out. And what they're doing is right now they're building this entire structure that's going to slide over this so that it tries to keep that nuclear radiation intact. So there are, of course, consequences. Most of the time, the issues with nuclear energy is the fact of either human error or a lot of times they build these close to water areas. So if we have a tsunami or we have an earthquake, we have problems. So we need to just think about better locations. The problem is we need a lot of water to run nuclear power plants because we need that constant source of water. So what happens is the nuclear rods produce heat. It boils the water, which creates steam that drives the turbine. And then that water, that boiling water goes into these cooling tanks where it's then cooled down and condensated back into water again. So there's just a lot of issues with this reactor core, and if this reactor core gets too hot, if, for example, what happened in Fukushima was when the tsunami happened, it knocked out power to the pumps that pumped this water to cool the reactors. And then what happened was the reactors caught fire and burned this area, which then released it into the atmosphere. So big problems, big problems. So the environmental impacts, the benefits and costs are, of course, are hotly disputed, especially in terms of nuclear, open pit mines, thermal discharge. What if there's a meltdown with radiation leak? The waste is a big problem. So once these reactor rods are used and they no longer can produce heat anymore, we need to store that radioactive material. This is where Yucca Mountain comes into play. There's been a lot of talk about actually transporting this nuclear material, which is kept on site, to Nevada, where we have this mountainous region where we've carved out a mountain and created a lab in there to store the nuclear energy. So you'll read a little bit about Yucca Mountain, this section too, in terms of where to store this. One of the big things is nuclear energy really doesn't produce any greenhouse gases, so it is an environmental improvement, but of course it has its downsides. This shows you Chernobyl. It shows you that this area here was where the complete reactor core meltdown happened and released all of that energy. And that was a big deal. And that fallout happened across Europe. I remember this as a child. I remember Chernobyl happening. And so it has long-lasting consequences. There's still people there today that have problems throughout this whole area. There are a lot of people who have thyroid cancer because of the radiation. And what I'm going to do is I'm going to put up a wonderful little video on Chernobyl in this section so that you can have an idea about it. This also is, this is the Yucca Mountain, where we're trying to come up with ideas on how to store the spent nuclear rods. Do we keep them underwater, which is what this is? They're kept underwater so that they can stay cool, but there's just a lot of questions about it. And of course, here is, in the past 25 years, the U.S. Department of Energy has been working on the Yucca Mountain Reserve, where we would actually drill, you can see it here, drill below this mountain resources, carve it out, and then store these nuclear reactors underground in hopes that nothing ever happens where they are released to the atmosphere. Okay, so this ends part two, of the lecture on non-renewable energy resources.